Hi, good day. Welcome in today's episode of DepEd TV. I am Sir Jason Flores, also your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Is your self-learning module ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to, first, define arithmetic means, and second, determine arithmetic means of a sequence. Previously, you learned how to determine the nth term of an arithmetic sequence. What's new? Well, we will focus on finding the arithmetic means. For example, in the sequence 4, 8, 12, 16, 20, and 24, find its arithmetic means. Well, 8, 12, 16, and 20 are the arithmetic means of the sequence because these terms are between 4 and 24, which are the first and last terms respectively. But what are arithmetic means? The first and last terms of a finite arithmetic sequence are called arithmetic extremes, and the numbers in between are called arithmetic means. Again, the first and last terms of a finite arithmetic sequence are called arithmetic extremes, and the terms in between are called arithmetic means. In the sequence 4, 8, 12, 16, 20, and 24, the terms 4 and 24 are the arithmetic extremes, while 8, 12, 16, and 20 are the arithmetic means. Also, 8 is the arithmetic mean of the arithmetic extremes 4 and 12. The arithmetic mean between two numbers is sometimes called the average of two numbers. Again, the arithmetic mean between two numbers is sometimes called the average of two numbers. However, if more than one arithmetic means will be inserted between two arithmetic extremes, the formula for the common difference d, which is d is equal to a sub n minus a sub k all over n minus k can be used, where a sub n is equal to the last term and a sub k is the first term of the sequence. Let's try. What is the arithmetic mean between 10 and 24? Using the average formula, get the arithmetic mean of 10 and 24. That is, adding 10 and 24, that's 34 divided by 2, 17 is the arithmetic mean. Let's go to the next example. Insert 3 arithmetic means between 8 and 16. If 3 arithmetic means will be inserted between 8 and 16, then our a sub 1 or the first term will be equal to 8 and a sub 5 or the last term will be equal to 16. Using the formula for d, compute for the common difference. That's d is equal to a sub n minus a sub k all over n minus k. We will substitute this in our given problem. Our a sub n will be the last term. So that will be equal to a sub 5 minus our a sub k. We will use the first term, that is a sub 1 all over n. We will use 5 and for k, we will use 1. Using the values for a sub 5 and a sub 1, we will have 16 minus 8 all over 5 minus 1. 16 minus 8 will give us 8, and 5 minus 1 will give us 4. Our difference now is equal to 2. Using the common difference 2, we will solve now for a sub 2, a sub 3, and a sub 4. A sub 2 is equal to the sum of the first term plus the difference. Our a sub 1 is equal to 8 plus the difference, which is 2. Our a sub 2 is equal to 10. For a sub 3, that is the sum of the second term plus the difference. Our a sub 2 is 10 plus the difference, which is 2. Our a sub 3 will be equal to 12. And for the fourth term, that is a sub 4, is equal to the sum of the third term plus the difference. Our a sub 3 is 12 plus the difference, which is 2. Our a sub 4 will now be equal to 14. Thus, the three unknown terms, a sub 2 is 10, a sub 3 is 12, and a sub 4 is 14. For the next example, let's try to solve for the missing terms. Get your pen and paper. Ready? Find the missing terms of the arithmetic sequence unknown for a sub 1, 6. The third and the fourth terms are also unknown, and 30. The arrangement of the terms tells us that the second term, or a sub 2, is equal to 6, and a sub 5, or the fifth term, is equal to 30. We are supposed to find the first term, or a sub 1, the third term, a sub 3, and the last fourth term, or a sub 4. To find for the unknown, let us first determine the common difference, d. That is, d is equal to a sub n minus a sub k all over n minus k. From the given values, we will substitute. You will have d is equal to our a sub n is a sub 5 minus our a sub k, which is the second term, that is a sub 2, all over, we will use n here as 5, and our k as 2. Next, use the values for a sub 5, which is 30, minus the value for a sub 2, which is 6, over 5 minus 2. Then, you'll have d is equal to 30 minus 6, that is 24, divided by 5 minus 2, that is 3. Our difference is now equal to 8. Since we have our common difference of 8, we can now solve for the missing terms. For a sub 1, or the first term, that is equal to the second term minus the common difference, which is 8. A sub 2, which is 6, minus the difference, which is 8. Our first term now is equal to -2. For the third term, we will use a sub 3 is equal to the sum of a sub 2 plus the common difference. We will use the value for a sub 2, which is 6, plus the difference, which is 8. Our third term is now equal to 14. And for the fourth term, you'll have a sub 4 is equal to the sum of the third term plus the common difference. Using the value for the third term, that is equal to a sub 3 is 14 plus the difference, which is 8. Our a sub 4 is now equal to 22. Therefore, the three unknown terms for this sequence are a sub 1, -2, our a sub 3 is 14, and our a sub 4 is equal to 22. You did great on that part, dear students. Now, let's have more activities for you. Let's solve this problem together. What is the arithmetic mean between the two given arithmetic extremes? Item number 1, 5 and 19. And item number 2, 3x squared plus 8 and x squared minus 6. Let's deal first with the first item, 5 and 19. We will use the average method. That is, getting the sum of 5 and 19, and we will divide it by 2, since we only have two numbers. 5 plus 19 will give us 24 divided by 2. Therefore, the arithmetic mean of these two numbers is 12. Item number 2, we will use the same method. We will use the average method for this item. So that is the sum of 3x squared plus 8 plus x squared minus 6. Remember to align similar terms and your constant. Getting the sum, we will have positive 2, and that is 3 plus 1, you have 4x squared. Is this your final answer? No, we will divide this into 2. Dividing this into 2, you will get 4 divided by 2, that is 2. Simply copy this variable on the exponent. 2 divided by 2 is 1. For item number 2, the arithmetic mean is 2x squared plus 1. Let's have another example. Insert the specified number of arithmetic means between the two given arithmetic extremes. Insert 3 arithmetic means between 2 and 22. The arrangement of terms tells us that the first term, or the a sub 1, is equal to 2, and the fifth term, or a sub 5, is equal to 22. Therefore, we are looking for the unknown terms a sub 2, a sub 3, and a sub 4. Before that, let us first determine the common difference d. Again, we will be using the formula d is equal to a sub n minus a sub k all over n minus k. We will have d is equal to a sub n. We will use the last term, or a sub 5 minus a sub 1 divided by, for n we will use 5, and for k we will use 1. Next, use the values for a sub 5 and a sub 1. You have d is equal to a sub 5 is 22 minus a sub 1, which is 2, divided by 5 minus 1. Our d is equal now to 22 minus 2 is 20, divided by 5 minus 1, that is 4. Our d, our difference, is equal to 5. Now, we will use the common difference d to solve for the unknown terms. For a sub 2, we will get the sum of the first term plus the common difference. That is, a sub 1 is equal to 2 plus the difference, which is 5. Our a sub 2 is equal to 7. For a sub 3, we will have the sum of the second term plus the difference, that is a sub 2, that is 7, plus the difference, 5. Our a sub 3 is equal to 12. And for the fourth term, we will have a sub 4 is equal to the sum of a sub 3 plus the difference. Our a sub 3 is 12 plus the difference, which is 5. Our a sub 4 is equal to 17. Therefore, the second term is 7, third term is 12, and the fourth term is 17. Easy, right? Congratulations for a job well done. I hope you learned something new, especially in computing the arithmetic means. For the next part of this lesson, try to answer the following questions. Number 1. How do we find the arithmetic mean of two arithmetic extremes? We can find the arithmetic mean of two arithmetic extremes by using the averaging method, which means getting the sum of the two numbers and dividing it by 2. Question number 2. When two or more arithmetic means are inserted between two arithmetic extremes, how are they computed? When two or more arithmetic means are inserted between two arithmetic extremes, they are computed using the formula in finding the common difference, which is d is equal to a sub n minus a sub k over n minus k, and adding the difference to the preceding term to get the next term. Amazing! For the next part, show what you can do by answering the following questions. What is the arithmetic mean between the given arithmetic extremes? X, second term is unknown, 9x. For this problem, we are going to use the average method, that is, adding x and 9x and dividing it by 2. X plus 9x will give us 10x divided by 2. The answer is 5x. Next problem. Insert the specified number of arithmetic means between the given arithmetic extremes. Insert 2 arithmetic means between -5 and 1. For this problem, we will use the formula in finding the difference, which is d is equal to a sub n minus a sub k over n minus k. Using the values for a sub n, we will use 1 minus a sub k is negative 5 divided by n, which is 4, and k, which is 1. 1 minus negative 5 will give us 6 divided by 4 minus 1 is 3. The answer is 2. Using the value of the common difference, we can now solve for the unknown terms. For a sub 2, that is the sum of the first term and the common difference. A sub 1, which is negative 5, plus the common difference 2, a sub 2 is equal to negative 3. For the third term, we will have the sum of a sub 2 plus the difference. Our a sub 2 is negative 3 plus the difference of 2. Our third term is negative 1. Great job, dear students! And that concludes our lesson for today. See you on the next episode. This has been your teacher, Jason Oso. Bear in mind that learning math will always be fun and easy. Be Oso, be awesome. Only here on DepEd TV.